Hello friends, in the previous video I have discussed about the electrode potential and standard electrode potential. Now question arises, how can we determine the electrode potential of an unknown electrode? For this purpose we have to construct one galvanic cell using one reference electrode. Now what is this reference electrode? This is the electrode whose electrode potential is known to us. There are number of reference electrodes are there, but one of them is standard hydrogen electrode. Standard hydrogen electrode, that is also written as SHE. Is it clear? Now first we will discuss about this SHE, standard hydrogen electrode. This is the diagram of this standard hydrogen electrode. In this, platinum electrodes are there, and these platinum electrodes are coated with the platinum black. Now what is the meaning of this platinum black? We can say actually this is a finally divided platinum, that is known as platinum black, and this is coated on the platinum foil. So this is the electrode in the standard hydrogen electrode, and this electrode is dipped in a acidic solution. This is acidic solution, and a pure hydrogen gas is bubbled through it. This is hydrogen gas we pass to this one. The concentration of both the reduced and oxidized form of hydrogen is maintained at unity. It means the concentration of hydrogen solution, H plus solution, is also 1m, and concentration of hydrogen gas, this is expressed in the bar, and that is 1 bar. Okay, so both are 1. Now in this case, this indicate that pressure of hydrogen gas is 1 bar, and the concentration of hydrogen ion in the solution is also 1 molar. It can be represented like this. This is platinum. This is used as an inert electrode. What is inert electrode? It is not taking part in the chemical reaction. It only provides the support to take the reaction, for taking the reaction. This is H2 gas, and this is H plus. And arbitrarily it assigned as zero potential at all temperatures. So we can see SHE has zero potential, and its electrode reaction can be written in this way. This is H plus aqueous, gain the electron, and this will convert into half H2. This electrode, that is SHE, may be used as cathode as well as anode. This we will discuss in the later case. Is it clear? This is about standard hydrogen electrode. Now measurement of electrode potential. Actually, the potential of individual half cell, that is individual electrode, cannot be measured because neither the oxidation nor the reduction reaction can occur by itself. Actually, both oxidation and reduction takes place simultaneously. But in a half cell, only either oxidation or reduction reaction is taking place. That's why potential of individual half cell electrode cannot be determined. Then what will we do? We can measure only the difference between the two half cell potentials, that gives the EMF of the cell or cell potential. If we arbitrarily choose the potential of one electrode, then that of the other can be determined with respect to this one. And the electrode whose electrode potential is known as reference electrode, as we already discussed that SHE is one of the reference electrode, and its standard electrode potential is taken as 0. To measure the electrode potential of an unknown electrode, we will construct a galvanic cell using this unknown electrode and SHE and determine its cell potential or EMF. And from this EMF of the cell, the reduction potential, which is considered as a standard electrode potential of the other half cell, that which is unknown, can be determined. It means first we construct one galvanic cell. In this galvanic cell, one is the reference electrode, which is SHE, and another is the unknown electrode, and we will determine its EMF. Now just see, this is the one example. This is the one cell we constructed using, this is hydrogen electrode, and another is the copper electrode, and we determined its EMF, that is come 0.34 volt. Is it clear? Now as we already discussed, that is, what is the cell potential? Cell potential is the potential difference of electrode potential of a right electrode and electrode potential of the left electrode. Is it clear? And this symbol, this represent the standard. This is the standard. Is it clear? Now question arises, in this cell, which, how can we say that which one is right electrode or which one is the left electrode? As we already discussed, that right electrode is the electrode at which anode, which is the anode, and oxidation is taking place, and left side electrode is the cathode and reduction is taking place. Okay, now in this case, actually on the basis of deflection in galvanometer, we can find out the direction of current. Is it clear? And we already know direction of current is from cathode to anode. If you know the deflection, we can find out which one is cathode and which one is anode. And in this cell, actually this we have determined with the help of either voltmeter or galvanometer, that will come 0.3 volt, 0.34 volt, and right side electrode, that is a copper electrode. Is it clear? And left hand side electrode is a hydrogen electrode, and will electrode potential for hydrogen electrode is 0. Then we have to find out the electrode potential of this copper. Okay, then apply this relationship. E standard cell, this is equal to E standard of copper electrode, because this is right hand side electrode, minus electrode potential of hydrogen electrode. Put the value, and this is equal to 0.34, as E cell is 0.34, and then we can say this is equal to electrode potential of copper minus 0, and finally this result in the, this is standard electrode potential of copper electrode is 0.34 volt, and this corresponding to this reaction. Is it clear? In this way we can determine the electrode potential of copper electrode. See one more example. If we construct the galvanic cell by using hydrogen electrode along with the zinc electrode, this is zinc, again we determine its cell potential, and this will come 0.76 volt, and with the help of deflection in the galvanometer we can find out the direction of current, and with the direction we can see which one is cathode and which one is anode. In this way we can say, in this galvanic cell, that is right hand side electrode will be hydrogen. Clear? And zinc will act as a left hand side electrode, that is cathode is zinc and hydrogen electrode is a anode. Okay, put the value, then in this way we can find out this one. Now as we already discussed that hydrogen electrode can be used as anode as well as cathode, so we can say with the zinc this is used as a anode, and with the copper this is used as a cathode. Okay, and for this zinc electrode, this is the half reaction. Again remember, half reaction is always written in the form of reduction, because standard electrode potential, by convention standard reduction potential is considered as a standard electrode potential. Okay, now next. Now, positive value of the standard electrode potential for copper electrode indicates that Cu2 plus ions get reduced more easily than H plus ions. As we already discussed, what is the reduction? In terms of electron transfer, we can say addition of electron is reduction. So Cu2 plus can easily be reduced to Cu compared to the H plus ion and convert into Cu solid, and reverse process cannot occur. It means hydrogen ions cannot oxidized copper, again remember, we already discussed that hydrogen gas is not liberated with the copper metal. Is it clear? This can be explained on the basis of positive value of the copper electrode, or we can say that is hydrogen gas can reduce copper ion, but hydrogen ion cannot oxidize copper. Okay, and this we already discussed. Copper does not dissolve in HCl, but in nitric acid copper reacts, but that is not hydrogen gas is liberated. In that case it is oxidized by the nitrate ion and not by hydrogen ion. What is the meaning of this negative value of standard electrode potential for zinc electrode indicates that hydrogen ions can oxidize zinc. Hydrogen ions can oxidize zinc, or we can say that zinc can reduce hydrogen ions. That's why zinc liberate the H2 gas when treated with dilute acids. Okay, now with the help of this we can find out the EMF of Daniell cell, as this is the reaction taking place in Daniell cell which we discussed in the previous video. Zn plus Cu2 plus gives Zn2 plus Cu. In this case, which one is the left electrode? That is where oxidation takes place. Now how can we find out the oxidation? We are having the two ways, by the transfer of electron or by knowing the change in oxidation number. Is it clear? You can say here oxidation number is 0 and this convert is the 2 plus. That's why we can say increase in oxidation number is oxidation and this is the your reduction. So we can say oxidation, that is a left electrode, and reduction, right electrode is copper, and we can find out the EMF or cell potential of this Daniell cell. E right minus E left. Right side is copper electrode. Its electrode potential is 0.34 volt and this is minus, and this is minus 0.76 is the electrode potential of zinc electrode, and this will come 1.10 volt. Metals like platinum or gold are used as inert electrodes, like in standard hydrogen electrode we have discussed. They do not participate in the reaction but provide their surface for oxidation or reduction reaction and for the conduction of electrons. For example, platinum is used in the following half cells. About this hydrogen electrode we already discussed, that is PTH2, this H plus, and this half cell reaction can be written this H plus plus electron converting into half H2 gas. Bromine electrode, see this is PT, this is Br2 aqueous, Br minus, and half cell reaction is half Br2 plus electron converting into Br minus. These are written in the form of a reduction. Is that clear? Now, after discussing these electrode potential, if we arrange these electrode potential in a decreasing or increasing order, then we'll get one series. That series is known as electrochemical series. We can say that is about activity series you discuss in the lower classes. Activity series is a small part of this electrochemical series. So a series contains the species arranged in sequential order. In some book and the species are arranged in the decreasing order. In some books they are arranged in the increasing order. That's why we are using the word sequential order of standard electrode potential. This is known as electrochemical series. Now just have a look of this. This is the one electrochemical series. Now just see this one. This is the reaction taking place. First, if we see F2 plus 2 electron converting into 2F minus, this is a reduction process is shown. Okay, so we can say actually this F2, this is the oxidized form and it gained the electron and this is reduced. That's why we can say this is 2F minus is the reduced form. That is on the right hand side of the reaction, reduced forms are represented, or in the left hand side oxidized forms are represented. Clear? Now again, if you see the value of the standard electrode potential, so for this fluorine this is 2.87. if we down this series, then this is decreases and lowest value come for this is lithium, Li plus plus electron converting into Li solid. This is minus 3.05 volt. Okay, now what conclusion we can find out from this electrochemical series and what is the use of this electrochemical series? See, the standard electrode potential decreases from top to bottom. We already discussed this, and what it indicates with this decreases the oxidizing power of the species on the left. Oxidizing power of the species on the left, that is this side. This is the left. Down the group, this is oxidizing power is decreases, and if we see above this is oxidizing power is increasing, and increases the reducing power of the species on right hand side. This is your right hand side. If we go from this top to bottom, then reducing power of these species will increase. Okay, we will take the two extreme case. Standard electrode potential for fluorine is the highest in the table, indicating that fluorine gas has the maximum tendency to get reduced to fluoride ions, that is F minus. Clear? Higher the value of standard electrode potential, it means more easily reduction takes place, because these standard electrode potential are the reduction potential. Okay, so we can say F2 will easily reduce to the F minus. More easily reduction, it means more powerful oxidizing agent. So we can say fluorine gas is the strongest oxidizing agent and fluoride ion is the weakest reducing agent. I think this is clear. F2 is considered as a strongest oxidizing agent because it has highest value of electrode, standard electrode potential. Now opposite extreme case, again see this. If we see down, lithium has the lowest electrode potential, indicating that lithium ion is the weakest oxidizing agent. Now, opposite to it, if we consider the opposite process represent the oxidation process. Then we can say if Li is converting into Li plus, that is, if we consider the oxidation potential is highest for lithium metal, that's why we can say lithium metal is the most powerful reducing agent in aqueous solution. In case of metals, if you are asked to arrange the metals in the increasing or decreasing order of their reducing power, then how can we arrange? If we know their standard electrode potential, more negative standard electrode potential means more reducing power. More negative standard electrode potential means more reducing power of that metal. Is it clear? Now, again, if we see, there is the one situation that when zero reduction potential is there, this is this one. Now, for which species? This is for H2. This is for H2, that is 2H plus gain 2 electron and converting into H2. If the standard electrode potential of an electrode is greater than zero, then that is above the hydrogen, greater than zero, then its a reduced form is a more stable compared to hydrogen gas. Is it clear? Reduced form, which is the reduced form, that is, these are the reduced form. These are more stable compared to the hydrogen gas. Okay, or in simple way we can say that is these species cannot displace hydrogen from dilute acids. Okay, like this copper is there, this copper will not liberate the hydrogen gas with dilute acid. In the same way, this is silver will not displace the hydrogen gas from dilute acids. Similarly, if the standard electrode potential is negative, then hydrogen gas is more stable than the reduced form of species. That is, if we can say hydrogen gas is more stable from these. That's why these metals can replace hydrogen from dilute acids, and H2 gas is liberated when these metals are treated with the hydrogen gas. Okay, so this is the utility of this electrochemical series or electrode potential. Other these, we can find out that electrochemical cells are also used for determining the pH of solution, solubility product, equilibrium constant, and other thermodynamic properties, and for potentiometric titrations. Okay, students, thank you.